It's like, it's so everything is except for like one part of one.
And we don't know that.
Yeah, that's how I did not read anything.
Maybe, yes.
That's pretty good. It's like we were stuck in the fire. And I'm like, they were like, you show them it's like long Europe is it's not good for like the parties for like then he said it's like oh yeah it's just it's like I was like, aren't you lost the phone job? That's like the funny thing is that oh no, that's my plan. And then we find out and there's this quadrant that's also related to us.
Hi guys, thank you for attention. Welcome back. Hope you guys have a nice and restful break. So we're going to start with BC specific topics. Now, these are all topics that should have been with certain units like arc length, distance travel should have been with the area volume, logistic models, Euler's method, it should have been with differential equations, improper integrals, integration by parts, all that it should be with the integration unit. But I just purposely pulled all the BC topics from first semester and just combine it and I just call it miscellaneous. So that I could just have first semester just be purely AB and then second semester just be purely BC. So these are a lot of these are not connected to each other. They're just topics that we need to know for the BC exam. So there's not a really strong link between any of these topics except for the fact that we need to know them. So today we'll start with integration by parts, and I'll go over the calendar here. Wednesday we'll do linear partial fractions or partial fraction decomposition, which is really another way of dealing with integral rules that we haven't seen before. Evaluating improper integrals, this is where one of the bounds is either infinity or at an asymptote. Next up, Euler's method. This is kind of like linear approximation, but a little bit more detailed than that. Okay, next up, logistic models with differential equations. This should be going with differential equations, but I pulled it out just for because it's BC topic. And then arc length and distance traveled. This is basically taking that distance formula and applying it to not a straight line, but a curved line. So after we get through all of these topics, we'll have a good number of days to do quiz review. And then not next week, but the week after, we'll have a quiz just over these topics that we are going to cover. Now, there's also all these homework assigned, but I realized from last year that I think there's enough practice in the packet where we can just focus on the packet and the AP practice. I want us to get that AP practice, but we can just really treat these as practice problems. So if you want practice problems or you want to come in for help sessions, we can go over them. But your assignment is just going to be to finish off the classwork problems in the packet for that section, as well as the AP problems, but we can skip the textbook problems. Okay. For every day, right? So for instance, today we're going to probably get through pages 1 and 2, and then you guys will finish off pages 3 and 4. And then tomorrow I will check your homework for completion of pages 1 through 4, as well as AP practice. I put the AP practice, I think near the, after all the notes, I think. Yeah, so page 42, you guys see that. Page 42, integration by parts. You'll be responsible for the AP practice problems as part of your homework as well. But as far as the problems from the textbook pages, these are just additional practice. I'm not going to check them for homework. I do have all of these though, the classroom problems, the AP practice, as well as the textbook problems, all worked out on my website. So you guys should have instant access for solutions where you can check your progress. Okay, page 1. So integration by parts. This is a method of integration useful for problems involving product of two different types of functions, examples, logs and polynomials. So on the AP exam, you're not going to be able to be told, oh, this is integration by parts. You're going to apply this rule. It's more like you're going to go through your checks in terms of integrating a problem. Is it power rule? If it's not power rule, then it is a use substitution. If it's not use substitution, and then maybe it's long division or synthetic division. And then if none of them work, then typically it's probably going to be integration by parts. And the giveaway is that you have two different families of functions that are being multiplied with each other. And you realize, wait a second, use substitution is not allowing me to get the x to cancel out. How can I deal with these two disconnected functions? And typically that's indication, okay, maybe there's integration by parts that will handle this type of problem. So integration by parts is typically used for integration of product of two different types of functions. And so this is kind of like a rearranging of product rule. But let me write the formula first. This integral of f times g prime of dx is equal to f times g minus the integral of f prime of g. So it's rearranging product rule from derivatives and rearranging them in a way that can be helpful for us to set up and solve these certain types of integral problems. So again, it's based off of the product rule. Let me just kind of show you how we can get from derivative product rule into this formula. So we know the derivative of f of g, in other words, the derivative of f times g is equal to f prime g plus fg prime, right? We know that. So what if we were to rearrange this? Let me just kind of show you how we can get, now, really, we don't have to really know this in terms of, just want to kind of show you the connection between this and the derivative rule. So I'm going to rearrange this here. So I'm just subtracting that f prime g over to the other side here. Now, what if I were to take the integral of everything that I see here? So the integral of this. Then I can say the integral of fg prime, which is this, is equal to the integral of derivative of fg, which second derivative tells us, second theorem tells us this will cancel out to be just fg minus integral of f prime g. So we're basically rearranging the derivative product rule and then just take the integral of it. And that is going to allow us to get to this form that is helpful for these types of problems. And this is basically this, just rearranged. So I pulled these notes from another website, and I'm going to show you kind of two different ways to identify certain information here. So the basic rule for choosing f and g prime is if you want to integrate by parts, you have to decide which part is f and which part is g prime, and go from there accordingly. And for f, they say to choose something that becomes simpler when you differentiate. For g prime, they say to choose something that can easily be integrated. Another way to think about finding that f value, I have u value here. These steps are using a different set of variables. I'm going to stick with f and g here. Is using this acronym LIPET, or I've seen this as well, LIATE. So really, the order is not really going to matter that much. The important thing is that L comes first. The L is first, the A is second, and then the T and E are last. So this is a way for us to identify that F value for our problem. The priority order for my F value. So L stands for logs. I stands for inverse trig, which we're really not going to see much of. We can basically ignore that. A represents algebraic or polynomial. It doesn't have to be polynomial. I like algebraic a little bit better because something like a 1 or an x falls under that algebraic rule, even if it's not quite a polynomial, like x squared or x cubed. And then T is trig, and E is exponential. So if you see a log, algebraic or trig or exponential, and you're trying to decide, wait, which one is the f, which one is g prime, whichever comes earlier in this acronym is going to take the priority order, which means that if there's a log and you're trying to do integration by parts, the log is always going to take the priority and take the place of your f. Now, if you're dealing with algebraic and trig or algebraic and exponential, then the algebraic term can be your f, and then your trig or exponential can be your g prime. So typically, these problems are going to be where logs are paired with algebraic, logs are paired with trig or exponential, or algebraic is paired with trig or algebraic is paired with exponential. typically we're not going to see trig paired with exponential. Usually your problems will always involve logs or algebraic.
See what is inverse trig.
We're not going to see, yeah, we're not going to see inverse trig. So, yeah.
Yeah, does it restrict in any using the unique sample?
It's unlikely. Typically, if you see inverse trig, it's just like, oh, can you find the derivative? And it's usually in the multiple choice section. Yeah. So I forgot to put in an example 1. So let me put in example 1 before I try this example 2 here. So if you can find space for number 1 here, we're going to do the integral of x sine of x dx. And if you look at this, trying to, if you didn't know this was integration by parts, the first thing you would probably try is, oh, maybe this is u substitution, right? But if you think about u substitution, there's no u value that will allow this to turn into something that that we can use, right? If you replace u with x, technically you use x in terms of u, but that's not going to help progress the problem, right? If you do u substitution, you're always replacing something greater than just an x with u. So if my u value is sine of x, the derivative is not going to cancel out the x. So we know u substitution is not going to fit this problem. But we do see 2 distinct types of functions here. We have an algebraic with the x. We have sine of x, which is trig. And so integration by parts should be able to allow us to move forward with this problem. So because x takes a priority over sine of x, in the priority order, algebraic comes before trig. So x is going to be my f, and g prime is going to be my sine of x. And I'm also going to attach the dx with my g prime. So let's do this. F is equal to x, and g prime is equal to sine of x dx. So that's the most important thing here is identifying the correct f and g prime. Okay. Now from here, we need some additional information. We need f prime and we need g. So to get from f to f prime, we just find the derivative. X's derivative is what? 1. Okay. Now to get from g prime up to g, we're going to take the what? Integral, antiderivative. What's the antiderivative of sine? Negative cosine. Yeah, I know it's opposite, right? Derivative of sine is cosine, but the integral of sine is negative cosine. There is a plus c, but we'll leave that to the end. Okay, so eventually that plus c will show up, but let's just focus on getting the formula in place. So here's our rule, right? We have f and g prime figured out. We just have to build out the right side here. F times g, so that comes first. So f times g, x times negative cosine x, which I'm going to combine to be negative x cosine x, minus the integral of f prime g. The integral of f prime g. We have everything that we need. We just have to pull it in the correct order here. F prime g. So minus the integral of negative cosine of x. So this is technically our established integral of my original problem. But whenever you do integration by parts, there's always going to be an incomplete part you have to do on your own. You have to find a separate rule for your leftover integral. So let me clean this up here. Negative x cosine of x plus the integral of cosine of x. Now, even though there is still an incomplete portion, we should be able to use a previous rule, an easier rule, to find the remaining integral. What's the integral of cosine? Sine. So negative x cosine x minus sine of x I'm sorry, plus. Cosine becomes positive sign. Plus C. So again, to recap, typically you're not going to know on the AP exam that something is integration by parts until you discover that use substitution doesn't work. And you realize, oh, this is a good fit for integration by parts because I have two distinct functions that are being multiplied that are from different families of functions. And then you can go through your priority order here, your acronym to identify your F and G prime. And once you get that, you're going to find your F prime and you're going to find your G using derivative and integral process. And then you're going to fill out the right side using the definition of integration by parts. But whenever you do that, there's always going to be a leftover portion that still needs attention. Okay, we can't just apply the rule and be done. There's always going to be this integral that you still have to resolve to get to your final answer. And then finally, plus C, if it's an indefinite integral problem. Any questions here? Now, there's a shortcut to this method, but the shortcut can only work if there are no logs involved. Okay, if there's logs involved, you're kind of forced into this process. All right. So here's example 2. Integral of x to the 4th sine of x dx. This is called the tabular method. But before I go through this method, I want to show you why the shortcut method is potentially useful for problems that are nested. So don't write anything down yet. I just want to show you this process. Let's say we were to go through integration by parts using the previous method that we just learned. Integral of x to the 4th sine of x dx. My f value will be x to the 4th since I'm dealing with a polynomial and a trig. My g prime will be sine of x. F will become 4x cubed derivative. G prime will become sine becomes negative cosine. And then I'm just doing fg minus integral of f g prime. Sorry. Fg minus integral of f prime g. So I know this piece is unresolved, but in order to do this, I need to go through what? If I want to find the integral, is this an easy process? I got to go through another set of integration by parts, right? And that's no fun, right? Having to do another integration by parts within a large integration by parts, that can be a tedious process, especially if there's like 3 or 4 problems nested within each other. Yeah.
In Lipit, there's ET, and then for Liate, there's
So the E and T, the order is not going to matter. Yeah. As long as you know they're last. So in order for us to avoid having to deal with all these messiness of these nested problems, there's a pattern that can allow us to get to our answer a lot faster. And that is where this tabular method is going to come in handy, especially if we have these nested integration by parts problems. So in this case, we can still allow our f to be x to the 4th and our g prime to be sine of x because there's no logs involved, and algebraic is going to win out over the trig. So we're going to create 2 columns, f and g prime, and let f be x to the 4th, and let g prime be your sine of x. Now on this side, you're going to keep finding the derivative until you eventually reach 0. And that's going to tell you how many times to take the antiderivative on the g prime side. Okay, so let's go down this column. X to the 4th becomes what? Okay. Keep going. Okay. Keep going. Okay. And finally, 0. Okay. So this tells us when to stop. On this side, we're going to keep taking the antiderivative until we reach the same number of times that we did f prime. Okay, so sine becomes then positive cosine, then sine, and then negative cosine. So this is a little gimmicky, but it allows us to get to our answer faster. Okay, so this is how we're going to do it. There's going to be a pairing between the two columns, but they're going to be paired diagonal with each other. So starting with the upper left term, these will be multiplied with each other. So x to the fourth will get multiplied with negative cosine of x. 4x cubed goes with negative sine of x. 12x squared with cosine. 24x goes with sine. 24 goes with negative cosine, and we ignore the 0. And there's something else. The first term, you're going to multiply with a positive 1. But then each subsequent term is going to be multiplied with an alternating negative 1. So the first one gets multiplied with a positive 1, the second one with a negative 1, then multiply with a positive 1, then negative, then positive, then negative. Now, technically, we don't need to worry about that 0 since that 0 is not going to be used in our answer. So some students have asked, wait, why is there this alternating sign that we got to keep track of? And the reason why is because whenever we go through these nested integration by parts, what's showing up in front of every integration by parts? Negative. And that negative is going to keep changing the sign of everything that comes after it. And so that's what's causing that negative, positive, negative, positive. Okay. So now we just put it all together. Negative x to the fourth cosine of x plus 4x cubed sine of x plus 12x squared cosine of x minus 24 x sine of x. Sorry, yeah, minus 24 x sine of x minus 24 cosine x. This is an indefinite integral, so don't forget a plus c at the end. It's tedious, but it's a lot faster than having to go through the original integration by parts rules. Now, what I've seen students do is, even if a problem is not nested, I think a lot of students still prefer to go through this method, which is fine. Okay, you can go through this method every time, unless there's logs involved. If there's logs involved, we have to go through the original rule because we're not able to get to the derivative of 0 if it's natural log. Okay. So this is great for a non-log integration by parts, but if there's logs involved, we got to go back to the original.
What's the sign again?
Sorry, say it again.
What's the sign to know that to use tabular?
Oh, if there are two, well, first off, use assumption doesn't work. And second, you realize, oh wait, this is a good fit for integration by parts because I have two different types of functions. I have polynomial and trig, and there's no logs involved. Then that's the indication that, okay, typically students would prefer to go through tab method. This, even if this did not, for instance, this problem, this one that we did before, you could go through tab method and get to the answer. You don't have to go through this integration by parts formula. But it's not bad, right? This integration by parts, we don't have to go through a whole nested thing, but. Okay. So today we're just practicing with these two methods. Next page. So let's not do the tab method until examples 3 and 4. For 1 and 2, I want you to try going through the original formula again. So go ahead and try 2. I will work through the problem same time that you guys do. I'll write the formula up top. Any questions with 1? All right, careful with number 2 here. In order for us to get from g prime to g, if I want to take the antiderivative of cosine of 3x plus 1, I got to go through a little bit of what? U substitution. Yep, U substitution. Not chain rule, got to do U substitution here. So your U value is 3x plus 1. So basically, cosine becomes sine, but there's going to be a leftover what from that U substitution? 1/3, right? Okay, any questions up to this stage here? Getting that fg minus integral of f prime g. This piece is complete. This still needs attention. So this one is another one. Another U substitution. But we already know what's going to happen, right? What's going to come out of 3x plus 1? Another what? Another 1/3, right? So if you understand, oh, that's just a nice clean 1/3 that's going to come out of it, you can just find the integral of sine, which is negative cosine, and then include a 1/3 as part of the coefficient to resolve that. So once you understand that pattern, you don't have to go through a full U substitution steps. To save a little bit of time. So I'm merging a few steps together without having to go through every little step here. I know that sine becomes a negative cosine, so the two negatives becomes positive. I know the U substitution from this will produce another 1/3. So 2/3 times 1/3 is 2/9. And don't forget plus 3. Any questions of 1 and 2? Right, so for 3 and 4, let's practice now with tab method. Okay, so let's do the tab method for 3 and 4. Yeah, it's going to produce another 1/3, right? So the integral of. So I like to create a table that looks like this, and I can just list out my f primes and then list out my integral on the right side here.
X squared, see, I got algebraic or.
It's algebraic. Remember, exponential is if I have a constant raised to a variable, like these are exponential.
Okay.
But if I have a variable raised to a number, that's polynomial or algebraic.
Okay.
Any questions with 3? Number 4, I want you to try tab method as well, but we gotta be careful with that e to the 3x plus 1. There's gonna be a little bit of U substitution that's gonna come out of it. But once you find the pattern, you just repeat that pattern and not have to go through U substitution every time, right? Once you figure out that pattern, just apply that pattern to each subsequent integral. So e to the u becomes e to the u, but that 3x plus 1 will produce a 1/3. So each time we take the antiderivative, another coefficient 1/3 will show up. Number 5, what do you notice is different? Oh. Yep. And what else? They're balanced, yeah. So we got to worry about the bounds at the end. We can't just stop with plus c. We got to evaluate the bounds. But we can't go through tab method, right? Because there's natural log involved. If we use f being natural log, we're going to not be able to have a stopping point. So we're going to let our f be our natural log, and our g prime be our x to the fourth. Natural log's derivative is u prime over u. And power rule antiderivative for that g prime to g. So fg minus integral of f prime g. Fg minus integral of f prime times g. This piece is unresolved. We still got to clean this up, take the antiderivative. Once all this is cleaned up, then we get to a half bracket and then plug in the upper and lower bounds. I'm just cleaning up that second term here to get it ready for power rule. Okay. So x to the fourth becomes x to the fifth over 5. Now we can plug in our upper and lower bounds. Upper bound first. Now, natural log of e squared, I can continue cleaning up because I can use power. Power property, bring that 2 down in front. Natural log of e is just 1, so Natural log of 1 goes away. That's just going to be 0. And then negative, negative, I get plus 1. Oops. 25th. There's another 5 here. I want to make sure I do number 6 before class ends. So here's number 6. Now this one doesn't feel like it's integration by parts, right? It looks like it's just one function here. But can we force this into 2 separate functions? I can have natural log of x times what? 1, yeah. And I can treat 1 as what? It's algebraic geometric, or sorry, algebraic polynomial, right? It's not quite polynomial, but 1 technically is algebraic. So natural log of x is my f, and 1 is my g prime. So technically, we don't have an integral rule for natural log, but using integration by parts, we're able to still find the integral. Yeah, we have fire drill today. Okay, fg minus integral of f prime g. This piece is finished. We just have to resolve the integral of 1 dx, which is x. Okay, your homework is to complete the rest of these pages, pages 1 through 4, as well as the AP practice near the back of your packet. All right, come get your phones.
Now, when it goes scale, something like that.